So hello, good morning, good afternoon, and good evening to everybody who's tuning in. I hope that you're all doing well and staying safe. On behalf of SB University of Nweze Student Chapter, I'd like to welcome you to the second session of TECHLOG training. So my name is Zakaria Maghabi. I'm a Master Degree Petroleum Engineering student at University of Nweze, and I will be your moderator for today's session. So since we had some technical issues the last session, it was necessary to reschedule another one. So here we are with another session about work correlation and environmental of deposition with Mr. Nweze Chukwudi. So before we start, let me kindly remind you to drop your question in the chat box down below during the session, so I can have the time to collect them and ask the instructor to provide you with the answer at the end of the session. It will be more structured and organized and professional like that. So now, without any further delay, please welcome with me Mr. Nweze Innocent Chukwudi. Mr. Nweze Innocent Chukwudi is a technically motivated, adaptable, and responsible petroleum and gas engineering graduate from Porosity University with interest in reservoir characterization and geomechanics. He has a methodical approach to work and strong drive to see things through completion. In his current job, he has been involved in the full completion of a field development plan as regarding bidding for an oil and gas field. Engineer Nweze, we're very delighted to have you among us today, and the mic is yours. Go ahead. So if you can hear me, you can start.
Yeah, thank you very much for that wonderful introduction.
You're most welcome.
You are once more welcome to this makeup class for our 1 month internship brought to you by the organizers. And so actually, I was not that happy with our last class, and it was actually a technical fault from my own end, and we were not able to continue with the class due to that technical fault. So today's class was actually fixed to be a makeup class for what happened in the last class. So I might not be going too deep. I will just ensure that I stop where I was supposed to stop in the previous class, so that by Friday, next tomorrow, we are going to actually continue with the course lecture. So once more, you're welcome. Now, we are having just 22 participants, which I know that we're actually more than this. And I believe that this class, although, it's been recorded so that links will be sent across to students or to participants that are absent in order for them to actually get the videos and follow up with the class as soon as possible for those absent today. Now, we should all know that one thing with the work in the industry, it all requires practice. Now, you might actually take on this course, and if you don't practice it, if you don't grow in your experience, you will end up forgetting all you've learned in the course of this 1 month internship. So I will urge each one of us to actually make out time from our busy schedules and look at how we can get all this practice in order to improve on our efficiency in using TECHLOG software. So once more, you are welcome, and I know that today's own section will be worthwhile. So just sit back and watch me take you through this training. Thank you. From my previous class, I talked about the TECHLOG interface, where I introduced the title bar, the menu bar, the toolbar, the project browser, the output window, the property window, the workspace manager, the palette editor, the zonation window, the markers manager, the contact manager, the action manager, and the saving bar. Now, in our course of working with TECHLOG, I will also, with time, go back to highlighting all this interface that I just mentioned. So it's not something I would like to explain again, but just relax yourself as we are getting used to TECHLOG, we'll get to understand those interface. Please, you help me to be admitting those persons into the class. I don't want to get distracted with it. Now, going straight to what we have today, we'll be looking at how we can import our data to TECHLOG, how we can actually import our data to TECHLOG. Now, I showed us the previous video from our previous class, the data we'll be using in this training section. And I also sent the data to the organizer. I believe that those of us using our software in our PC now should have gotten that data from the organizer so that you can actually work with me in the course of this training. Now, I'll go straight to getting that data extracted. Okay. Now, hope you can see my screen. I divided my screen into two, one containing my TECHLOG my PowerPoint slides, and one screen showing my TECHLOG software. Please, if you can see the screen like this, do let me know, please.
Yes, sir, we can see both of them. Yes, sir.
Oh, yeah, thank you. Now, how we can bring up our data into our software. I showed us the last time how we can see our data to know what and what is being contained in our data. Now, today, I'll be showing you how we can actually import data into our software. Now, if you come to your menu bar, you see your home tab in your menu bar. In your menu bar, we are having projects, home, plot, data, utility, studio, petrophysics, geology, geomechanics, and so on. So this is actually our menu bar. So if you come to the home bar in your menu, you will see import. So once you click on import, let me try to hide this. Let me shift my property to my left side. Okay. So when you click import, you'll be having, here is the project browser. This is my project browser. As I clicked on import, I'm having this attached to my project browser. So what I will do is for me to click on this folder icon where I'm having my files import. There's a folder icon attached to it. I'll click on the folder icon, and it's going to bring out an interface being this. I'm moving it right now. I don't know if you are seeing it. I'm actually moving it. So I'm going to locate where my data is being stored in my PC. My data is found on my desktop. So So I'll go to my desktop, and here I will see my training data. So I'm going to open the folder up. Now, the first one that is in last file is my well data, while this other one is my deviation data for both well. So I'm going to bring in my well data. I'll select it and click on OK. It's here already. So since it's here, I will take a look at it. Please note, once I click on this drop down, the drop down actually helps in showing the content of a particular file in the software. Like you are seeing here, once I click on the drop down, it shows me this. Once I click on this drop down actually means that there are files contained in this. So I will click on this drop down. Now I'm seeing that in this my well 4, that is spelled O4, I'm having my depth log, I'm having my caliper log, I'm having my density log, I'm having my DTC log. DTC log means compressional sonic log. Compressional sonic log. I'm having my GRO log, which is my gamma ray log. I'm having my NPHI, which is my neutron porosity log. And I'm having my resistivity log. So these are the logs that are attached to file O4. So what I will just do is that I will select it. As I've selected it, I'm going to use this arrow here to push it into my project browser. I've selected it. I've pushed it into this place. Hope you are all following. So if I've done this, what I'm going to do next is I'll select this again and I will delete it so that I can import my deviation file. Please note, if you are working on a feed that contains more than one well, the same way we brought in this well, you can select as many wells as possible and get all of them pushed into your project browser. It follows the same process. Now coming to importing a deviation file. Importation of deviation file is somehow different from importing your well log file. Now you are going to see it. Let me try importing the deviation file. These are deviation file. I click on open. I click on open. I see the interface that is shown here. Hope you are seeing the interface shown here. My deviation file, as I told us from the previous class, that it actually contains measured depth, our azimuth, and our inclination. And I give us reason why we're importing a deviation file. A deviation file helps us to convert our measured depth to our total vertical depth. It also been used to do a depth correction because we don't actually include elevation height into our well log depth. So getting your measured depth, azimuth and inclination, and also your reference depth, either it being reference to your calibration or your mean sea level, any of these, we use this to estimate our total vertical depth, sub-T, or total vertical depth calibration. So that is just it. Now, for this data, our measured depth, the unit is in feet. Now you can decide to scroll down to search for feet, or you type FT on your keyboard. It will take you to feet. Now the unit of our azimuth is in degree. So you can scroll down or you just type D and search for degree. You also do that for inclination, which unit is also degree. Now, after you've done that, now we're having our survey data. Our data set type is going to be because our depth is trajectory. Now, I'm importing from line 1. I'm importing from line 1. My variable name starts
Hi, sir. You get disconnected. If you can hear me. So it will be better if you share your screen and you hide your cam, because the network is a little bad from your side. We can't hear you, sir. You're unmute.
okay. After all this has been said, I'm sorry for that. After all this has been said, you come to load to the import buffer. Load to the import buffer. Now, if you see here, this place is actually our import buffer. So what you are seeing here is a well deviation for PEL 04. Now, one of the errors that actually comes up during importation is when your well data file, the name of your well data file does not match or correlate with your deviation file. Like here, I'm having, this is carrying the same name as this my well data set. Since it's carrying the same name as my well data set, since it's carrying the same data set, let me click on the drop down. Now, I'm going to push in, I'm going to go my well data set. Now, can you see this?
Sir, if you can hear me, your sound is not clear. Most of the participants can't hear you. So if you can't hide your cam and use network only for sharing your screen. It will be better. Most of the audience said you have voice disruption. So if you can hear me, so please, sir, if you can hide your camera and you use your network
please,
just for sharing. Okay. If you can repeat just
okay,
the last 1 minute.
I can. Okay, I can hear you, and hope you can hear me clearly now.
No, yes, now I can hear you. Yes, now I can hear you. Yes. Yes. And from the audience, if you can hear
okay,
him now,
I'll like other part.
well, let me know. Okay.
I'll like other part.
They said yes.
Please.
You can go ahead, sir. Yes, they said yes. They can hear you well.
I'm just. Can I go on?
Yes, yes, you can, sir. They can hear you. You can go ahead.
Okay. So I just brought in my survey data, and I trust that you all followed the process or the steps I used in getting this done. So after you've imported your well data and your survey data, what you just need to do is to close your import buffer, to close up this buffer. And you can do that by clicking on this cross sign here. That is, will I call it the multiplication sign, but it's actually the close symbol, it's close icon for the import buffer. So if I click on it, I've closed it up. Now this is the data we'll be working with. We'll just be working with one well, or we'll be working with two wells. I think I'll bring in the second well in our next class, because we'll have to do our well log correlation. I can't just use one well to. So I'll need two wells. I'm going to again so that now after you've done this, now all we need to do now is to view our well log. And you can only do that okay, someone is asking if I could repeat how to get. Viewing our well log, I told us from our previous in your menu bar, come to plot, and you are going to see a log view. Now this is our log view. You like to close this down. Now, depending on the kind of interpretation you want to carry, that will tell which well log you are going to display. Interpretation is first for us to identify our lithology, and our lithology are basically two, being a sandstone formation and a shale formation. So the log that will give us a better lithology identification from what I've been provided is our GRO log. That means the first log we are going to display, or the first log that is best suitable for display, should be our GRO log. And how can you display your GRO log? You select your GRO log and you drag and drop it on your. If someone see what I'm doing, I select my GRO log, I drag and drop on my log view. Now, my GRO log, how can I get it conditioned so that I can actually go about my interpretation that I'm going. After our lithology identification, the next thing we should be looking at is which reservoir is hydrocarbon bearing and which reservoir is water bearing. Now we can know which reservoir that is hydrocarbon bearing and that which is water bearing through the use of our resistivity log. From the previous class, I explained to us that resistivity is the impediment to flow of electrical current via a material. Now, we can say that resistivity is the opposite of conductivity. Now, if we have a spike in resistivity, say we have a high resistivity, it tells us the kind of material found in that formation. If we have low resistivity, it's actually telling us that the kind of material found in that formation or the kind of fluid found in that formation is actually a conducting material because it have low resistivity. Note, either a material have high conductivity and a low resistivity, or a high resistivity and low conductivity. But in this case, we are just considering two fluids, being our water and our hydrocarbon. Hydrocarbon, I mean my oil and gas. So than a hydrocarbon. That means water have high conductivity and low resistivity, while a hydrocarbon have low resistivity and high conductivity. So what we are going to do now is we'll bring in a resistivity log. A resistivity log will help us to know which formation is hydrocarbon bearing and water bearing. But if you look at my resistivity log here, you see that this log is actually graded out. Graded out is this log is not bold as compared to these other logs. This log is not bold as compared to the other logs we have in the well. Now the cause of this is just tied to one thing. That means a log is not being assigned to a family. Most times you will see that your log does not have unit when you see it graded out like this. Now this is how you know. You expand this. I see. I just want to show something. I see the training data. This is the data. This is the family, and this is the unit. Our depth is assigned to measure depth family. Our caliper log is assigned to our caliper family. Our density log is assigned to our bulk density family. Our DC log is assigned to compressional slowness family. Our GRO log is assigned to our gamma ray family. Our NPHI is attached to our Neutron porosity family. Our resistivity log is not attached to any family. That is why it's being graded out. That is why it's not as good as other well logs. So what we are going to do is that we are going to assign it to a family. Most times it might not be just the family. Most times, even if it's been attached, it's been assigned to a family and not been assigned to a unit, it will also experience this error. So for you to correct for this, is either you assign your well log to a family or you assign your well log to a unit. Assigning well log to a family, what you just do is select the well log, you right click on the well log, and you're going to see assign to family. Assign to family. Now the arrow pointing this way is going to bring up a dialog box. Now what you are going to look for is you are going to search for resistivity. Now my resistivity is at the bottom. This is my resistivity. Now I'm going to follow this arrow to search for my deep resistivity, which is this. I seen this. This is my deep resistivity. So I'm going to select it. Now I have assigned my resistivity log to a family, being the deep resistivity. I seen that it's now bold, deep resistivity. So after I've done that, I'll just select and bring it into our well log view. I've done that. And these are resistivity log. These are resistivity log. Now I'm going to explain this area for us. Immediately I'm done reviewing the well logs that are of importance to us. Now after I've done this, now the next log that we should be looking at to carry out our evaluation or quick look interpretation is actually a neutron porosity log and density log combined. Now these logs actually help us in our fluid discrimination. Fluid discrimination in the sense that it tells us which formation is hydrocarbon bearing, which formation hydrocarbon bearing, that means I mean my gas and liquid hydrocarbon. Liquid hydrocarbon is referred to oil. So it differentiates between our gas hydrocarbon, our oil hydrocarbon, and our water in the formation. That's what we actually use our neutron porosity and density log combined for. Also, our neutron porosity and density log combined is also used for our lithology identification. It's also used for lithology identification. When I have displayed the log and conditioned it, I will show us what I mean by saying it's also used for our lithology identification. Now, to bring in this same log, we follow the same process. We select a neutron porosity log, we drag and drop. This is a neutron porosity log. Now, our density log, I want to combine the density and the neutron porosity log together so that I can differentiate which zone is gas bearing, which zone is oil bearing, and which zone is water bearing. So what I will do, I will select the density log, I will drag and drop it on top of my neutron porosity log, on top of this log. I'm not taking it outside the log. I'm dropping it on top of the log. I have dropped it. I seen this. I seen this that there's actually a cross plot between your neutron porosity and your density log. Now, this is just the 3 log or the 4 logs we'll be working with for now. So I would like at this point for each and every one of us to hit up the chat box. If you have a question to ask, hit up the chat box. If you are following, also hit up the chat box. Let me get feedback from you guys before I continue with the class. Thank you. Okay, I think I will continue because I don't have much time. Now, after we brought in all this, now the way our well logs is being displayed is such that it will be difficult for us to interpret this log. Why? First, because of its view and font. Now it will be good if the font of your log view is actually portable, so as for you to see to a particular depth in just a glance of your log view. In order for us to edit this, the first place we're going to go is to go to our property. Now, the first conditioning we are going to do is to increase the scale of our view. I would like to take it to 1:1000. I see that I experienced some changes here. Taking it to 1:1000. This is just it. Now, let me also try another scale. 1:500. I think. So the more you play with this scale, you actually zoom in and zoom out of your well log. 1:2000. These are 1:2000. Now, if you've done this, you can also condition your well log by closing up the space closing up the space. Okay. Now, if I want to close up the space for my depth log, take note, the first log here is my depth log. The second is my GRO log. The third is my resistivity log. And the fourth is my NPHI log. Now, this depth log, the font size of my lettering is too big. So if I want to close it up, I'll just come to the track. I'll select the track. I'll go to my property and I'll go to appearance. From this appearance, I'm going to edit on my grid font. I'll place it at 6. Click on OK. I see that I've changed the font of my depth log so that it can be portable. I also do that for my header, which I'll also come to property. At appearance, I'm going to see header font. I'll also change it to 6. Take note, you experience a change here. I see this. So this is just the little change you will see. This is my reference left. Now, after we've done this, I think I should expand this a little. Okay. After we've done this, I would like to shade, I would like to confuse my resistivity log so that I can know which log, which formation is hydrocarbon bearing, where it's giving me a spike in resistivity. So for me to do that, I will take my cursor to the curve. Now, one thing I have not explained earlier is that there's a difference between curve and track. Your curve is your log, while your track is what is containing your log. From this point to this point is a resistivity track. This is called, this other part of this portion here is called a track. This to this point is a track for resistivity. From this point to this point is a track for gamma ray. From this point to this point is a track. So this is a track header. This is a track header. This is a track header. Now, this zigzag movement here is what we call the curve, and our curve is our well log. So please, you should take note. Most times I'll try to differentiate, or most times I'll try to let you know when I'm working with my curve or when I'm working with my track. Now, for you to copy your resistivity log, take your cursor to the curve. Select the curve. If I click on this resistivity curve, it will change its color. I see that its color changes from red to blue. And sorry, from blue to red. So if I've done this, I'll now right click on the curve. I'm going to see confuse to the lower limit. Now, I am seeing that I have my 0.2 to 2000. So I'm asking TECHLOG from this 2000, confuse to the lower limit. That means it's going to give me a backfill. A backfill, I mean from my right to my left, or from the center, or from the curve to the left. From the curve to the left is add fill to the lower limit. So I'm starting from my higher limit to my lower limit. So if I click on add fill to the lower limit, it's going to bring out this. I'm going to select the palette and I'm going to search for resistivity because that's my resistivity curve. I'm going to search for resistivity. Here is resistivity. I will select and click on OK. I see that I have configured my resistivity log. I have configured it. Now let's take a look at it. Now just take note of this part so that when you see a spike in resistivity, you can differentiate between your water-bearing formation and your hydrocarbon-bearing formation. Now, take a look at this point and this point. Now, please watch. Okay, I think I will work with these two, so I'll show you something. Now, I see this point here where I'm having my red color, or where I'm having a spike in resistivity. You see that the resistivity at this point is 33.6. 33.6. Now, the resistivity at this point, on this upper point, is what? 1.2. That means the resistivity here is higher compared to the resistivity here. And this resistivity is being experienced in my sandstone formation. So as a petrophysicist or a reservoir engineer or a geologist carrying out this interpretation, I can clearly state that this sandstone formation here is actually hydrocarbon bearing. Take note, this is not a carbonate formation, neither a formation that is containing brine that might actually lead to spike in resistivity. Here we are putting all those conditions aside. You can only get to know about those conditions when you carry out a real-time interpretation in your field, or so getting to test, or after your mod logging, you get to know if that formation is brine formation, because we mod log with depth. So that is just it. But from my well log, I can tell that this formation from this point up to this point is actually hydrocarbon bearing. So I will actually take note of that point. Now that's why I needed configure my resistivity log. I hope it's well understood. Now the next log I'm to configure is my Neutron porosity log and my density log combined. Now what I'm going to do now is I'm going to select my density log being the red curve. I'll select it. You see that it has been selected. I will hold my shift button on my keyboard and also select my Neutron porosity log being the blue curve. Once I click on it, it will change to red. Hope you are following. After I've done this, I'm going to right click on any of the curve, and you're going to see insert area fill between the variables. We are filling between the variables. We are not filling to any limit, be it the higher limit or the lower limit. We are filling in between variables. So I have confused in between variables. So I'll confuse in between variable. And so now I think from here I can explain what I mean by my neutron porosity log and my density log, that they are also a good, pointers to lithology. Now, if you see here, I'm having my sandstone formation here. You will see that it also tallies from this point to this point, showing that this point to this point is my sandstone. Wherever I'm having my shale lithology, it corresponds to the color of my neutron density combined cross plot. Same thing happens here. Here that I'm having my sandstone formation, I'm having it matched here. Now let me also go upward so that you can all see. I see all through this portion or all through this depth, I'm having my lithology, which also my neutron porosity, my neutron density log also states that from this point to this point below is my shale formation. Also, from this point to this point is my shale formation. It's also pointing out here from this point to this point is my shale formation. Now, a question might be asked, apart from our gamma ray and SP log and TECHLOG, which other log is a good indicator of lithology? Please note that your neutron porosity and density log combined is also a good indication of your formation lithology. I see that from here to this point, where I'm having my sandstone formation, I'm also having same here, from here to here also. Now, that is just that for our well log conditioning. Now, I just showed us how we can condition our well log. Now, another thing I would like to apply here now is how we can actually fit in this as survey data so as to convert our measured depth to TVDSS and just our total vertical depth. Now, for you to do that, for you to carry out a depth conversion, you're going to come to your data, where you have your data in your menu bar. There you will see your reference and coordinates. You click on the drop down, then you are going to see your TVD computation. That means we want to compute for our total vertical depth. And how we can compute for that is bringing in our survey data. Now click on my TVD computation. Now if I've selected my TVD computation, what I will just do is to push in the log that is needed for that. And from here, I'm seeing that my measured depth is needed, which I have in my survey data. My whole deviation is needed, which is my inclination. I have it in the survey data. And my whole azimuth is needed, which is my azimuth here that I have in the survey data. So what I'm going to do is to come here, locate this respective depth. Here I'm having my whole azimuth. I'll push it into my whole azimuth. I'm having my whole deviation. I'll push it into my whole deviation. And I'm having my measured depth. I'll push it into my measured depth. Hope you are following. If you've done that, you click on you just click on this crate. Now, an interface as this should be popped out. All you just need to do is select the survey data and bring in your data set into this portion and you drop it in. So if you dropped it, then you can now input all this other information. Now, the azimuth is reference to grid node. Most times, you leave it as undefined if the company also does not do not provide the azimuth reference. As for this data, the azimuth reference was not provided, so it will be left as undefined. Now, the elevation height for this, it can be your elevation based on your calibration or based on your mean sea level. Now, for this data, it was provided for our calibration and it's provided as 72.82 feet. 72.82 feet. The method of conversion. That is the method you want activity to be computed. We have so many methods of computing activity. We have a minimum curvature method. You have a radius of curvature method. You have a high tangential method. You have a low tangential. We have an average tangential, and we have a balanced tangential. These are different methods in computing your TVD. Now, the best method I use is my minimum curvature method. So I'll leave it as that. Now, my output reference should be my feet. My output sampling rate should be every 0.5 feet. Now, this field type, this data is an offshore data. If you are working with an onshore data, you can select onshore. But this data is an offshore data. So you've done that, you shift. Since it's an offshore data, you can give the water depth. Here, the water depth was not provided, so I'll leave it as null. And also, these other parameters can be filled, but for here, they are graded at, assuming it's for our onshore well, most of them will not be graded out. So if you've done this, what you are going to do next is to click on apply. Click on apply. Once you click on apply, you are going to see this pop out as your TL well path. If you click on this drop down, I see your MD. This your borehole azimuth, your borehole division, your dog leg severity, your true horizontal length. This is your total vertical depth or your true vertical depth. I see. This is your total vertical depth below mean sea level. This is your activity SS, that is total vertical or true vertical depth subsea, and this is X offset. So these are the different depth data that with my MD and azimuth I've been able to get. So if you've done this, you can actually close this up. Most persons find it difficult closing up a particular window they open. If you are finding it difficult, just below your minimize here, you will see another sub minimize or restore down. I think that I've restored this down. So all I'll just do is to close it off. Now my log data is still here. I can bring it to full view and so on. So I've succeeded converting my MD to my TVD. Now, this is just all we have for today. I don't know, by Friday, I'll be bringing in the second well log so that we can carry out a well log correlation, our environment of deposition. Then we'll go into a statistical evaluation in full. So I don't know if there's any question or if there's any place you want me to put you through again. I want you to actually go and practice this so that if you are having questions in the next class, you can also ask. So now is the time for questions and answers. Over to you.
Thank you so much, sir, for this insightful and wonderful webinar. Yes, actually, we have two questions. So the first question was about someone is asking how to get survey data, please. He didn't understand how to get survey data.
Okay, how to get your survey data?
Yes,
now,
exactly.
I explained earlier, for you to get your survey data, the same way you brought in your well log data, in the same way you are bringing in your survey data. But this time, it will take you through another part, and I'll just show you that once more. I'll come to my home tab. I'll come to import. This is my import buffer. Now there's a folder icon or file explorer icon by the side of my file import. I'll click on it. Once I click on it, here is my survey data. I'll select my survey data and click on open. Now it brings up this interface for me. All I just need to do is to enter the appropriate information in this interface and get it loaded. Now the first information I'm entering is which is my feet. So I'm bringing my feet. The unit for my azimuth, which is my degree. I find it and insert it there. Unit for inclination is also my degree. I select and put it there. My data set name, you can choose any name of your choice, but I've decided naming my own survey data. Now my data set type is now points data. My well log is my points data. This is actually my trajectory. So I'm going to put in my trajectory. So I'm importing from which line to which line? I'm importing from line 2. This is my line 2. No, I'm importing from my line 1. So I'm going to put here import from line 1 because from my line 1 you see I'm having my value. Now my variable name, which is this, is line 0, and my unit name is also line 0. So after I've done this, now your data type is delimited. Yours might come in LAS or ASCII or fee size, anyone. If you've done that, what you just need to do is to click on your load to import buffer. If you click on your load to import buffer, you're going to see your well data, the well division file at this point. What you now do is select it and push it in. That's all you need to do. Hope it's well understood. The next question, please.
Thank you, sir. So next question. What is the way to change the cutoff value of gamma ray log that separates between high values and low values?
Okay. The way we can go about bringing a high and low value from gamma ray log is to come to project in a menu bar. Sorry. Coming to that. Select your gamma ray log. This is your gamma ray log. Once you get it selected, you come to your properties. Are you following? If you come to your properties, now let me get this expanded. Now, are you seeing all these values? Now, it's something you can actually work with. Now, most times you can also come here. If you come here, I think the best place to go is your, come here, come to property. You see your main information. Okay. I see your minimum value as this and your maximum value as this. This is your mean value and this is your standard deviation value. Now, in TECHLOG, most of the time, you are not given an opportunity to actually edit any of these values. It gets plotted out the way it's been imported. But in other software like your interactive petrophysics and your Petre, you can get to work or play around with the minimum, maximum, and mean value. So that is just it. But if you're looking for a way to extract these values, these are the values as we have them in data. Thank you.
Okay, sir. So the last question: how to align the lithology's correlation of each word log? He means the marking zone.
How to do what?
How to align the lithology's correlation of each word log. I think he means by that how to know this is a shale part or sand part or sand shale part
Okay, how to identify
in the word log.
Now, this is just it. This is a simple correlation. From our previous class, I explained to us how we can, or what we can call our sandstone formation. And I told us about the presence of radioactive substances in our formation. In our sandstone formation, we have lower radioactive substance, and in our shale formation, we have high radioactive substance. So sending in our gamma ray tool, it actually helps to detect the amount of these radioactive substances in our formation. So if we have a higher value of radioactive substance reading or recording, it tells us that that formation is a shale formation. And if we have lower value of gamma ray or radioactive substance reading or GRU log, it tells us that it's a sandstone formation. Like what you are seeing here, from my mid value being my 75 below, tells me that from here to this point, I'm having low radioactive material found in this formation, which gives me my sandstone formation. And from this 75 above, I'm having high radioactive substances found in this formation, which tells that it is my shale lithology. So this is just how we basically differentiate between these two lithologies.
Okay, sir. So someone is asking about how to modify the survey data.
How to modify the survey data?
Yes, exactly.
Most times your survey data is being given such that you have different information in the survey data. That is where your data QC will actually come in. You can use any of these data analysis tools, which is more convenient for you. Like for me, I use my Excel to actually see my deviation data. With my Excel, I can just get those basic information I want. I can get my MD, I can get my azimuth, and I can get my inclination from any kind of deviation data given to me. That's how we can actually modify our deviation data to get it fit to be imported into TECHLOG. If your deviation data is not having the same format as mine, you might have it, you might have difficulty bringing them in into TECHLOG. So that's just it. You're using of these data analysis tools to carry out a modification. Thank you.
Oh, okay, sir. Thank you. So that's it for the question part. Thank you so much for your valuable time. And now to highlight, at the end of the training, you will have a final assessment about the 4 lectures, and it will be uploaded on Canvas platform. So be sure to register there. Beside that, today's session has been recorded, and it will be uploaded on our LinkedIn group. So stay connected, please, and have a nice day. Thank you so much, everybody.
Yeah, thank you all. Thank you, and have a nice day.